Good morning, students. We will have the complete introduction of the concept. What is the subject transmission lines exactly speaking about? So in the transmission lines, we have the continuation with respect to electromagnetics. The electromagnetics has the analysis of conductivity, permeability and the permittivity. These are the constants defined in terms of the intuitive parameters of skin depth, attenuation constant and the phase constant. When we move on to the transmission lines, there are two constants, primary constants and the secondary constants. Primary constants are resistor, inductor, capacitor and conductor, whereas the secondary constants are characteristic impedance and the analysis of propagation constant. Now to go into the subject, we'll have the classification of communications to be classified as wireless communication and wired communication. Wired communication is preferred for high speed, less challenges. For flexibility purpose, we go on for wireless. But the subject here is purely dealt in terms of wired communication, which has a classification of transmission lines, waveguides and the fiber optic. So the transmission lines in particular can be dealt in terms of two-wire, coaxial and the planar. So again, a simple classification in terms of transmission line and waveguide is chosen. So in transmission line, as we are going to speak about coaxial line, strip line and microstrip line, in the waveguide we will have an analysis of rectangular, circular, ridge and the flexible waveguides. Now this diagram very clearly depicts the electrical representation of the transmission line between the generating station and the substation. In between we have the transmission lines to be analyzed, and in case of a transmission line, equivalent circuit. This is the general representation between the source and the load. We are connecting the transmission line, or between the sending end and the receiving end we are connecting the transmission line, which has the equivalent circuit model consisting of the primary constants of R, L, C and G. Resistor, inductor, capacitor and the conductor, as we have already spoken. A small length is chosen for this purpose. And now we see the types of transmission lines based on distance and materials. Based on distance, we have AC and DC transmission line classification. Again in AC we have short, medium and long transmission line. As the name indicates, it is based on the length. But in medium transmission line, we generally prefer the pi model and the T model representation. When we go for the types in terms of materials and shape, we have various types in materials and shape based. So homogeneous or inhomogeneous, we'll see each one in the subject analysis. So in general, we define the transmission lines to be the high frequency electrical cables which are composed of two or more metal wires. Now we have the basic classification in terms of transmission lines and waveguides to be compared with. A transmission line is a conductor which is carrying the electrical signal over long range, whereas this is a hollow metallic structure for which electric and the magnetic field can travel through. This is complex structured and this is a simple structured one, and here the power handling ability is low, whereas here the power handling ability is higher. The operating mode in case of transmission line is called as transverse electromagnetic mode or quasi-transverse electromagnetic mode. But the operating mode in case of waveguides are TE and TM, transverse electric and transverse magnetic. In case of waveguide, the electromagnetic signal is transmitted. In case of transmission line, the electrical signal is being transmitted, and the operating frequency of the transmission line is about 18 gigahertz, whereas it is in terms of 100 gigahertz in case of the representation of the waveguide section. So we will see the complete details in the next session. Thank you.